In this video, we're going to take a look at some examples of solving quadratic equations by completing the square. And so you'll see that there are some steps involved here, and it's highly procedural. So as long as you can follow these steps, the numbers may be different, but the procedure is the same. So let's take a look at 24 here. I want to solve this using square roots, but it's in standard form. So if I could rewrite this as the square of a binomial, something like this, then it'd be a whole lot easier. But what I want you to notice is right now, I have something of the form x squared plus bx plus c, but the value of c is not equal to half of my middle term squared. That is to say that when you cut 6 in half here, half of 6 is 3 and 3 squared is 9. That's not what I have here. So what we're going to do is we're going to go through this series of steps that allows us to rewrite this as if it is a perfect square trinomial, and then we will be able to square it or write it as a binomial squared here. So we're going to take a look here. I'm not really sure what I just did there. There we go. At this, and we're just going to go through all these steps here. So step one is always just move this loose constant to the other side. So we're going to subtract that 3 over. So we get something that looks like this instead. X squared plus 6x equals negative 3. Now notice that the left side is in this form 1x squared plus bx. Now if we could just add in half of b squared, then this would be a perfect square trinomial. So step 2 here is after we move this constant to the right side, we are sure to have an a value of 1, which we do, and then we add half of b squared to both sides. So I tend to do it this way: x squared plus 6x plus, and I put in a blank, equals negative 3 plus the same blank. And so the idea here is that half of 6 squared would be 3 squared would be 9. We're going to put a 9 on this side, and of course what we do to one side we have to do to the other side. Notice now the left side is a perfect square trinomial, so I say factor the perfect square trinomial is our next step here. So we're going to write this as the square of a binomial. And on the right here we get negative 3 plus 9 is 6. So what would this factor into? Well, remember that once we have it as a perfect square trinomial, that it always factors into the square of this binomial, x plus half your middle term squared. So half of a positive 6 is a positive 3. You'll notice that now this is an equation that is no longer in standard form, but it's kind of in vertex form. And that is to say that we can just isolate this squared item and take the square root of both sides. So this is what I'd like to see you guys doing. Suppose we get x plus 3 equals plus or minus the square root of 6, which we'll just leave. And then we say x equals subtracting 3 over negative 3 plus or minus the square root of 6. These would be both of our zeros or our roots here. So we're going to try this one more time here. Again, something like this. I just want you to see it's procedural. We have x squared plus 2x equals 6. We'll move our constant over to the other side. We'll make room, okay, for the constant we would rather have here so that it's a perfect square trinomial. And half of 2 is 1 and 1 squared is 1, so we'll add 1 to both sides. So the left side now has to factor into the square of a binomial. As a matter of fact, it has to be x plus 1 squared. Half of 2 is 1. And this equals a 7. So again, just like last time, we're in a position now where we can take the square root of both sides. So we get just x plus 1 equals plus or minus root 7. And again, I suppose we would get, after subtracting the constant over, x equals negative 1 plus or minus root 7 here. So we're going to take really quickly a look at a couple of examples where the a value is not 1. Just as an additional step we're going to build in here. But this procedure still holds. So step 1. Say on number 33 here, we're going to move this constant over to the other side here. So I would have 5x squared minus 10x, and this equals a positive 21. Now what I want everybody to notice is that the left side needs to be in this form 1x squared plus bx. And at the moment we have something that is not 1x squared plus bx. We have 5x squared plus this bx here. So the fact that this is a 5, that's a problem. We need that to be a 1. So when I write up here on step 2, be sure to have an a value of 1, factor out any non-1 coefficients is what we're going to do here. Essentially, whatever's there, which in this case we have a 5, we're going to factor that out on the left side. So I would have 5 going out front. We would have 5 going out front. We get left with x squared minus 2x. Remember that we have to factor it out of both of these terms right here. So looking at something like this, I want you to look at the inner part. This is what I'm fixated on. Notice that my inner expression here has a 1x squared plus bx. So what we're going to do is we're going to build in our blank spot, but I want you to notice that it goes inside the parentheses here. And we're also going to build this into the right side, so there goes my blank. Now, what's half of negative 2 squared? Well, half of negative 2 is negative 1. Negative 1 squared is 1. We're going to put a 1 here. The thing you have to remember, though, is this. We're going to put 5 times 1 on the right. And the reason why is because when you factor out a non-1a value, you really factored out a 5. Or when you factor out this 5 and you put a 1 in here, if you redistribute that 5 through, we get our 5x squared, we get our negative 10x, but we also get a positive 5. So really what we're adding to both sides is 5. It just doesn't look like it because we put a 1 inside these parentheses where there was a 5 being distributed on the outside there. So looking at something like this, I want you to know that this inner part here is a perfect square trinomial. You'll notice the only difference between this and the previous two that we looked at was we have a 5 out in front. So when we factor this, we say half of -2 is -1. That goes inside. And 21 plus 5 would be 26. At this point here, we would want to solve this using square roots. So remember that using square roots, we always want to get the squared value by itself. So this 5 out front has got to go. We've got to divide both sides by 5. So we would get x minus 1 squared equals 26 fifths. If we take the square root of both sides now, we get x minus 1 equals the square root of 26 over square root of 25, or sorry, square root of 5. Remember that we always split our radical if we have a fraction on the inside, and I need to put a plus or minus out in front of this. Let's go ahead and rationalize my denominator here. So if I take it times root 5 over root 5, we would get instead x minus 1 equals plus or minus 5 times 26 is 130. So we get a square root of 130 over square root of 5 times square root of 5 is just 5. So we get x equals 1 plus or minus the square root of 130 over 5. Yikes! But these are our roots. So just know that if you have a non-1 a value, that on that second step there, be sure to have an a value of 1. You have to factor out that non-1 a value. Cheers.